Alright guys, we're gonna start going over this Unit 2 study guide on inequalities. And one of the most important things about this whole section are the symbols. So we're gonna quick review those first. We've got this guy, right? Looks like an L. So that's gonna be the less than symbol. And if it has the line underneath, that means that it could also be equal to, less than or equal to. Because our answer could be included. Okay, we also have the guy that goes the other way. It's the greater than symbol. And the greater than or equal to. Okay, so those four symbols are going to be really important for us to make sure that we understand what the problems are asking us. Okay, so on your test, number 1 is going to be kind of like this one, where you're just going to be given an inequality and you're going to have to graph it. Okay, so what we're looking for here is really this symbol kind of denotes everything that you're supposed to do. So the number that we're going to start graphing at is -3. So we're going to put a circle at -3. Draw. The next thing we're going to figure out is if we have to close that circle or leave it open. So the fact that the line is underneath that symbol means that the -3 is included in our answer. So it's a closed circle. Okay, and the greater than symbol, greater, means that we're going to shade that way. We're going to shade to the right. So shade to the right. And close your little arrow. So all of our solutions are greater than or equal to -3. So the last thing that we're going to do is just check it. -2 is a solution because it's greater than -3. 2 is a solution because it's greater than -3. 5 is a solution because it's greater than -3. Okay. All right, moving on. Number 2, what you'll notice here is that our variable is on the right side, which is really the wrong side. So we're going to have to flip-flop them. I don't know if you guys remember, but we did that interactive notebooks where we flip-flopped the variable and the number. So when you do switch them, when you do switch their order, okay, you are going to have to also switch the sign. So that instead of being a greater than symbol will now be a less than symbol. Okay, other than that, nothing else changes. Okay, you don't put the line underneath or anything. And you're just going to graph it like you graphed number 1. So that's an open circle at -1. Okay, we don't color it in, we don't include it because it's not equal to. And our symbol's this way, so we're going to shade to the left. Our arrow goes to the left. All right, great. 3B is taking a graph, so we're going to kind of do the reverse. Taking a graph and writing the inequality that we are shown by that graph. Okay, so you can see in 3A, the number is part of your answer. The closed circle means equal to, and we shaded left, so that was less than or equal to. So for 3B, you need a letter, the number, and our arrows going this way, just like our symbol would go this way. Okay, see how this symbol is the same as this symbol? And we're also going to make the decision whether to put that line underneath to show the inclusion or leave it the way it is. And this is an open circle, so we're actually going to leave it as such. All right, number 4. Now we have a little bit of a word problem situation. Okay, so 4A, he used at least 3 markers. So what I like to do is take this number, 3, and then ask myself, could he use 3 markers? Yeah. So then at 3, I'm going to color that circle in. Could he use 4 markers? Well, at least 3. Yep, he could use 4, and that would be the side that I shade. Okay, so like this one, she had less than $5. So our circle is going to be at the 5. Okay. Asking myself, do I close that circle? Is 5 included? Could she have $5? And the answer is no. Could she have $6? No. Could she have $4? Yes. And so we would shade that left side of our circle. Okay, so you kind of have to pick out your 1 point and ask yourself if the number higher than that number or the number lower than that number would work in this situation. All right, now the next couple are solving inequalities. Okay, so we're going to solve these exactly like we did equations, and then the only extra thing that we're going to have to do is graph them. So we'll draw our little line here, and we need to get x by itself, so we need to get rid of that -2. We get rid of a -2 by adding 2 to both sides. And we can use our calculator here, right? -1 plus 2 is +1, okay? Checking out right here, is our variable on the left side? If it is already on the left side, then we don't have to do any flip-flopping and we can just graph it. So we'll put a graph at 1. We have to ask ourselves, is 1 included in our answer? And that answer is no, because it's not equal to 1. And greater than means we're going to shade all of the numbers to the right. All of the numbers that are greater than 1, like 2 and 3 and 4 and 5. Okay, let's flip to the next page. There we go. Okay, now we're going to switch things up a little bit right here because now we have our variable on the right side, we have our constant with that variable, and then our answer on the left side. So when we go and solve this problem as we would do normally, okay, our constant is 3, so that's the number that we'll be getting rid of first. So subtract 3 from both sides. And in this situation, our variable is on the right. We don't want that. We want that variable to be on the left, so we're going to flip-flop them. And we're going to flip-flop that sign as well. So this will be our answer to number 6b. X is greater than 3. That's an open circle at 3. Okay. Do we include 3 in our answer? No, because this says x is greater than 3, not greater than or equal to. And so we're going to shade all of the numbers greater than 3, so we're shading to the right. All right. Moving on, we're going to start working with some word problems here. Sweet. You can see one of the word problems is modeled for you over here on the left side. We're gonna skip right to 7b, and we're gonna talk about Bill and his $75 gift card. Okay, he wants to buy jeans that cost $66. Write and solve an inequality to determine that additional amount Bill could spend without exceeding the gift card limit. Okay, so in this situation, 75 is going to be our total, okay, because that's how much the gift card costs. Could Bill spend more than $75? The answer is no, because he only has that $75 gift card, so he can't spend 76. So our symbol is going to be less than. The next question is, could he spend $75? And the answer to that is yes. So he can spend less than or equal to $75. Okay. In this situation, he wants to buy jeans that cost $66. Okay, so he's going to buy those, and he wants to buy something else, so we would add that other amount to the 66. So our inequality is going to be 66 plus x is less than or equal to 75. To figure out the number or the additional amount that he could spend, we're going to subtract 66 from both sides. Okay, 75 minus 66 is actually just 9. And he can spend, Bill, right, can spend at most $9. He can't go over that amount, but he could spend 9 if he wanted to. All right. Number 8 is now we're moving to 2 steps. All right, we're gonna get back to answering 8b right now. 8b is a one-step inequality. It has to deal with multiplication or division, and you're gonna notice that there's a fraction next to our variable. So the way that we get rid of the fraction or eliminate that fraction is by multiplying by its reciprocal. So the reciprocal of 1/2 is actually 2 over 1. And when we do that, we are going to get negative 10, because negative 5 times 2 is negative 10. We're going to graph this guy right here, open circle at negative 10, and we're going to ask ourselves, okay, is negative 10 included in our answer? And because it is not equal to negative 10, the answer is no. So that's going to be left as an open circle. Greater than means we are shading to the right, where all of the values are bigger than or greater than negative 10. Okay. 9b is a little bit different. What you're going to notice here is that the coefficient is what type of number? It's a negative. It's a negative 9. Okay, and when you multiply or divide by a negative number, you actually are going to flip the sign. So instead of it being less than, it's going to be greater than. Positive 72 divided by negative 9 is negative 8. So again, we're going to go to negative 8 on our number line. It is not included, and we're going to shade all of the values greater than negative 8. So we're shading to the right again. Lots of shading to the right today. All right, it's a little bit of a trick, so we kind of have to remember that if you divide or multiply by a negative number, meaning that negative number is your coefficient, you must switch the sign. Okay, little word problems here for you. Okay, so we have an example right here about baseballs. Now we're going to have an example about lip gloss. Lip gloss costs $1.25 each. Okay, the word each should jump out to you because it means multiplication. What are the possible numbers of lip gloss that can be purchased with $8? Okay, so that's your total. $8 is your total, kind of like that jeans problem and the gift card that we had before. Can I go over the $8? No. Can I spend $8? Yes. So that means that my lip gloss purchase needs to be less than or equal to that $8. Okay, $1.25 each is 125 times x. We're going to divide both sides because this is multiplication. We'll divide to get rid of the 125. And 8 divided by 1.25 is 6.4. So you can buy 6.4 lip glosses, okay, which is kind of weird because you can't buy like a 0.4 of a lip gloss. So if we need to buy less than 6.4, we're actually going to start at 6, 5, 4, 3, 2, 1, or 0, because we can't buy negative lip glosses. Is it glosses or gloss? I don't know. That's why I teach math, guys. All right, so the possible numbers of lip gloss that can be purchased would be 0 through 6. All right. Number 11B is going to be a multi-step inequality. We have distributive property, and then we're going to have to do 2 steps after that. So the first thing that we always do is get rid of the parentheses by distributing. 5 times x is 5x. 5 times 1 is positive 5. Okay, so we've got 5x plus 5 equals 35 right now. Going to try to get x by itself, so we're going to have to subtract the constant, which is going to be 35 minus 5 is 30, and then divide by the coefficient, which is positive, so we're not switching any signs, which is great. 30 divided by 5 is 6. Okay, my variable's already on the left side, so that's great. I'm going to put a circle at 6. Question is, do we include the 6? And my answer is going to be no, because there is no line underneath here to show that it could be equal to. Shading less than means we're going to shade to the left. And there you go. All right, great. 12B. Rich has a goal of saving more than $1,500. $1,500. More than. So that means whatever we do needs to be greater than 1,500. Could it be 1,500? And the answer to that is no. He wants to save more than that. Okay, so he already has 400 saved. And each, oh, there's that word again, each. Okay, each month he adds $50 to that amount. Oh my gosh, look, it's already here for you. How cool is that? We didn't even have to write that. All right, so he adds $50 each month to it. It can be solved to find the number of months it will take Rich to reach his goal. How many months will it take him to reach his goal? So we're just going to solve this. Subtract 400 from both sides. It's going to give me 50m is greater than 1100. 50 times m, so we're going to divide by 50. And we have 1100 divided by 50 is 22. So it's going to take him at least 22 months. At least 22 months. Really more like 23, because 22 is not included here. So it's going, you can use the words at least 22 to show that. All right, moving on. We've got another multi-step inequality right here. This time it's variables on both sides of my inequality sign. So what we're going to do is look and see, is there anything that we can simplify on this left side? The answer is no. Anything that we can simplify on the right side, and that's yes, we're going to distribute. So take a look at that. Now, how do we decide which variable to move? Okay, so we have 4x right here, and we have 2x right here, and usually what's easier for us to do is to move the smaller one, which in this case is 2x. So we'll subtract 2x from both sides. And now we're left with a two-step inequality. So we've got 2x plus 6 is less than or equal to 12. We'll subtract 6 from both sides, right? And divide by 2 to get 3. We have to graph it. So it's going to be a closed circle at 3 because 3 is included in our answer. It could be equal to 3. And we're talking about all the numbers that are less than or equal to 3, so we're going to shade to the left. Okay. 14b is a lot like 13b. variables on both sides. Okay, I don't have to simplify anything on this one, so that's kind of cool. I got negative 3x and positive 2x as my variables, and the negative 3x is actually smaller because it's a negative. So we're going to add 3x to both sides. Going to give me 4 is less than or equal to 5x minus 6. Add 6 to both sides. We're going to get 10 is less than or equal to 5x. Divide both sides by 5. I get 2 is less than or equal to x, and then I am going to actually flip them because I need my letter, my variable. Hang on. I need my variable to be on the left side. So it's a closed circle at 2, shaded to the right. Okay, we're going to move to the compound inequalities next. These are the ones where you have two choices. You have an and inequality that looks like a sandwich, or an or inequality where it says the word or. Okay, this one in particular, this is and. Looks like a sandwich. Got that middle expression right here. Okay, and the reason that we put a box around that is because the middle expression is going to show up twice. Okay, we're going to need to split these up because there are two inequality symbols. So we're going to split them up into two simple inequalities instead of this compound one. Start with the negative 3 is less than or equal to 4x plus 3. And then write the 4x plus 3 again is less than 15. So you can see that if I really wanted to, if I wanted to overlap these two and put the 4x plus 3 right on top of the other one, it would look like your compound inequality. Okay, so we've split them up so it makes it easier for us to solve. Okay, we're going to subtract 3 from both sides. Going to get negative 6 is less than 4x. Divide both sides by 4, and we're going to get negative 3 over 2. Oh man, it's a fraction, and that's okay. Subtract 3 from both sides. We're going to get 4x is less than 12. X is going to be less than 3. Okay, now we've got our answer for this guy and our answer for this guy, and we're going to combine them. And that's what we're going to graph. So again, if you put these pretty much one on top of the other, you put this x over this x, that's what it would look like. It would come back together to be like our initial problem. Negative 3 over 2 is actually like negative 1.5, so I'm going to put the circle in between negative 1 and negative 2, and I'm going to close it because of my symbol right here. Okay, the 3 is an open circle because the 3 is not included in our answer. Okay, what we need to remember about this is that and inequalities are going to shade in between, like a sandwich. And that is the answer to 15B. Okay, almost done. 16B is, look at that, it's an or inequality because it says it. We love or inequalities because they're already split up for us. So we are going to add 5 to both sides. Look at that. Add 18 to both sides. Divide by 9. And just stick the word or in between your two answers. Okay, I like or inequalities much better because they're actually already done for you, which is pretty great. We're going to have an open circle at positive 2, a closed circle at positive 3, oh, they're right next to each other, and or inequalities are shaded out. Or goes out. They look like oars on a boat. And that is your solution to 16b. Okay, 17b. We're just going to write a compound inequality. One day at band camp, the high temperature was 84 degrees and the low temperature was 66 degrees. Write a compound inequality to represent the day's temperatures. So if the high was 84 and the low was 66, that means that all of the temperatures need to be in between those two. Okay. Was the low actually 66 degrees? Yes. Was the high actually 84? Yes. There it is. All right. You don't have to graph or anything, so that's your inequality. Okay, we're going to talk about your absolute value inequalities right now. Okay, and we had this like really great way to remember whether they were and or. It was go, LA. Okay, so that means if it's greater than, it's an or. If it's less than, it's an and. Okay, we also could take a look at that and say it's great or. Okay, either way we know that this is going to be an or inequality. We have to make sure that absolute value is alone, which it is, and we're going to have to split that up because you know how with absolute value you get two different answers. Okay, so we just rewrite it. All right, and then we've got also switching the sign and making that a negative. Okay, so that's a split right there. That's how we split them up. Subtract 4 from both sides. 2x is greater than 2. Divide by 2. X is going to be greater than 1. Subtract 4. That's going to be negative 10. Divide both sides by 2, and x is less than negative 5. So we're just going to graph those two. Negative 5, positive 1. Okay, both of them are not included in our answer. We know this is an or, so our graphs are going to go out because ors go out like oars on a boat. Okay, let's flip. We're almost done. There's 3 more problems for us to do. 19b. Okay, so the first thing we've got to do is get absolute value alone, which it's not. We have to subtract 3 from both sides. Okay, and now we have to kind of like decide, is this and or is this or? And we're going to look at the symbol. This is less and. So and. I'm just going to split it up like we did the other one. X minus 2 is greater than negative 5. Okay, so this one again, that second one, you're going to flip the sign and you're going to negate that answer. Okay, so that just means put a negative sign in front of whatever number is in your original problem. Okay, add 2 to both sides. We're going to get x is less than 7. And x is going to be greater than negative 3. So there's 7. Closed circle, right? Because it's included. There's negative 3 right here. I know it's and, so I'm going to shade the middle because it's between. And if I wanted to write my answer as a compound inequality, looking all fancy, it would look like that. Okay? All right. Last but not least, we have our little open-ended problem about Tom. All right. Tom is going to solve this inequality below, and the inequality x represents the length of the rectangle. Okay. So pretty awesome. We don't have to set anything up. It's already done for us. So we just need to solve this. So let's do that. 6 minus 4x is greater than or equal to 10. Great or 6 minus 4x is less than or equal to negative 10. Okay, so subtract 6 from both sides. That's going to give us positive 4. Divide by both sides by negative 4. X is less than or equal to negative 1. Okay, we'll do the same thing over here. You got negative 4x is less than or equal to negative 16. I don't know if you guys picked that up over here, but if I divided by negative 4, so this sign right here got switched. I'm going to do the same thing over here as well and switch that sign. Negative 16 divided by negative 4 is positive 4. Again, these are ors. So let's graph the solution. Closed circle at negative 1. Closed circle at positive 4. We know it's an or, so we're going to shade out. Okay. Now, Tom says that x is negative 2 is a reasonable solution to the inequality. All right, so explain why Tom thinks that. Tom thinks that because negative 2 is shaded on our number line. So that's why he would think, yeah, sure, that's totally reasonable, but he's not right. And let's think about why. Okay, what do the answers represent? Okay, the answers represent the length of a rectangle. The answers represent the length of a rectangle. Length cannot be what? Negative. So the only solutions are if the length is greater than or equal to positive 4. All right. All done. Good luck on your test.